Good afternoon. I'm Marco.
And I'm Bob.
Today we're presenting the Sorting Hat, which is an intelligent waste item classification software. So the motivation for our project stems from a source of daily confusion, namely garbage classification. When an environmentally conscious soul approaches one such multiple choice machines, he or she might want to make the right decision in preserving the environment, but may not be able to do so, either due to negligence or sheer confusion. That's why we propose a better solution.
So for this project, we're trying to create a program that classifies waste items based on two inputs. The first one is its image, and the second one is a verbal description of it. So our software structure precisely reflects this. We have two models, one CNN that takes in a picture input, and one another neural net that takes in text. The results from those two models will be combined and weighted and output a final result that hopefully is more reliable.
So the source of data for our image portion comes from Google Images and ImageNet. They're web scraped and manually sifted through to rid of any absurd and wrongly classified data. After data augmentation, we have 8,000 images per class. So this is our first CNN model approach to the image classifier, and has 3 convolution layers with increasing kernel number and decreasing kernel size. Final accumulation map is fed into 5 fully connected layers, upon which one of 4 bins is outputted. And here you see the results. On the left, you see an 11 category classifier, and that were later hard-coded into 4 categories of the waste bin. And on the right, you see a 4-class classifier where all images are fed into directly, and it outputs one of 4 classes. And you can see it has a better validation accuracy. But we thought we could perform better, so we also tried to apply transfer learning. This is a new model, and we used an Inception v3 model pre-trained on ImageNet. We trained it by freezing all its parameters except for the last fully connected layer, which we replaced and trained on the training data set. So here are the results. As you can see, the training for the transfer learning model Inception was much better. This is expected because it's a much more sophisticated model, and it generalized more based on the entire ImageNet database.
Okay, and now for the NLP portion, we've also trained a neural network for this portion. And the training phrases, we got them from Toronto's Waste Wizard, which is an online list of common household items. We filtered the list to exclude items that are unlikely to be found in the school. And we also added phrases that we thought people might say to our machine. And our model is a simple 1 hidden layer, multi-layer perceptron with 4 output neurons. And despite the limited training data, we achieved pretty reasonable validation accuracy of 75%. And this is better than our first non-neural net model, which had 58% accuracy. So finally, we wanted to combine the 2 models and test them with our test data. So the test data were pictures that we took of actual waste items that we threw out over the past few days. And to combine them, we experimented with weightings of between 0.1 to 0.9 between the 2 models. And as you can see from this table, as you increase the weighting on the image classifier, the overall accuracy decreases. So that tells us our CNN does not generalize onto the test data. And we think the main reasons for this is because in our test data, there were pictures that were not present in the training data, such as coffee cups of a different color. And also in our training data, they were all nice-looking pictures, whereas in the test data, or pictures that will be actually inputted into the model, they were pictures of waste. And next time, we would also like to try transfer learning much earlier, because as you saw, the validation accuracy was much higher, and it was able to be trained much faster.
And this project also taught us a lot about coding practices, and it taught us to have better coding practices, including better structure of the code, so that later building on would be easier. And this also included variable naming. Sometimes you got confused with that, and the process of loading data itself. In addition, we also wanted to stress that debugging should occur on a sublevel on all submodules before putting together. And finally, it's that we need to record progress frequently to avoid a repeated training to get the same results.
Yeah, because we lost our progress halfway. Okay, and now we'd like to give you a live demo of some items. So here I have a pop can, and here's some paper. And if we have time, we'll do this bag of chips. OK, so this is our webcam. And what's happening is that our program is taking the last photo taken in the camera roll. So here we took a picture of our webcam. And so let's say we input PopCan as our phrase. And our CNN model outputs container. The language model also output container, which were both correct. So the combined model was also a container. So now let's try this paper. So again, we take a picture of it. And the program is getting the last photo from the camera roll. And now let's say this individual is more creative, doesn't want to say just paper, so he says flyer. Oh, and it also works. OK. And our yeah, and both the CNN and NLP model outputs paper, so the combined result is also paper. Let's try the chip bag.
Oh,
OK.
Just
Does anyone want to suggest a phrase too?
Chip bag.
OK.
oh,
OK.
CNN also actually
CNN
got
doesn't
wrong.
work, but the language model works.
What's the right answer?
The
Landfill.
landfill. So as you can see, the combined result is correct. OK. That worked better than we thought.
Wow, that's great. That was a lot of different things that you did, 2 different models and combining them. That's not easy to do. It made me wish that I kind of quoted, I think there's that book one of the books I put in the list of 5 books to read is Machine Learning Yearning by Andrew Ng. He has a whole section on choosing your test data versus validation versus that, which is what you just learned. They should come from the same distribution. And so, yeah, that's a good learning too. Great to hear about coding learning. That's hopefully an intended side effect of having to produce code.
And having to work on a project where 2 people have to work on the same code, which was a first experience for both of us.
Can you use GitHub?
Yeah.
Yes, we.
So when you were combining the results from CNN
Mhm.
and NLP,
Yeah.
so that parameter that you set the point between 0 and 1.
Yeah.
Are you just using that to do like a weighted average
Between the probability distributions of the 2.
I see.
Mhm.
Okay. Yeah, I was wondering like if you have tried like something like concatenating the predictions and then running another layer of like hidden layers.
Oh.
Whether like it might learn that if the CNN is predicting this and then NLP is doing that, it might still combine it in some other way, but.
Yeah,
Yeah,
that's true. So you created a miniature neural network with a one parameter.
Yeah.
And that was the weight. That's what you did.
Yes. Yeah. Uh-huh.